Continuing on with some additional examples from practice set 15. Problem number 23, taking a look at this as far as our priority, parentheses are number 1. We have expressions that are raised to the second power, an implied multiplication in the numerator and the denominator, and the fraction bar is indicating a division. It's going to act like a grouping symbol for the most part because we'll need to simplify the numerator and the denominator before we do the division. So replacing the variables with the values indicated, x is replaced with a 3, y with a -1. Our priority is, as previously stated, inside the parenthesis. We have a subtraction of signed numbers. We're going to use the rule of subtraction. The rule of subtraction states, change the sign of the second number. It's a -1. Originally, it becomes a +1, and we now add. I could simplify the denominator, but I'm going to hold off. Simplifying inside the parentheses, 3 plus 1, we're now going to replace that with 4. Looking at what we have in the expression, we have powers are our next priority following the order of operations. 4 to the second power means 4 times 4, which is 16. And then the denominator, 3 to the second power, can be replaced with the result from 3 times 3, or 9. As I mentioned, before we do the division, we need to simplify the numerator, simplify the denominator. The multiplication in the numerator, when we take 3 times 16, will result in a 48. The denominator, 5 times 9, is going to give us a 45. And finally, we get to do the division, grab our calculators, or simplify the fraction, is going to give us 1.0666 repeating. Problem number 23 has an implied multiplication, and we have a square root symbol. And underneath the square root, it has us multiplying and dividing. So before I can do any multiplication, I'm going to have to simplify the radical or the square root, and then I'll do the multiplication. So here, the radical sign is acting like a grouping symbol or parenthesis, essentially, and taking the priority before we do any multiplication. So let's replace the variables with the value given. Simplifying, and again, I could do the multiplication here, but I'm going to hold off. Simplifying underneath the radical, 2 times 2 is going to give us 4 over 9. Now the square root of 4/9, if I use my calculator, may not come out as the cleanest value, so I'm going to hold off and instead use the property for radicals that if you have the square root of a fraction, it breaks down into the square root of the numerator over the square root of the denominator. And perhaps you're familiar with radicals and simplifying them in the fact that 4 is a perfect square because of the fact square root of 4 can be broken down into a product of 2 times 2, the result giving us a 2. And likewise, we have the square root of 9, which 9 can be broken down into 3 times 3, giving us the result of a 3. Simplifying this expression, we now look at it and we have an implied multiplication, and a division. These first two terms have a denominator of 1, an understood denominator of 1. I can multiply the numerators and divide by 3, getting the same result as though I instead canceled out the fact that 3 divided by 3 results in a 1, leaving me with the 2 times 2 for a final answer of 4 for this problem.